This is part B of problem number 1. Again, we start with the 55 grams of oxygen, but now the problem asks to calculate how many liters of hydrogen will be used in the reaction to produce the 61.87 grams of water. So we start with the 55 grams of oxygen. Okay. But now we need to get to liters of hydrogen. So step number 1, transform grams into moles. Here I use the molar mass. This is 1 mole of O2. Remember that here what you have, if you stop here, is moles of O2. Then I use the mole ratio. We have 1 mole of oxygen per 2 moles of hydrogen. And if I stop the calculations here, I will have now moles of hydrogen. But these moles of hydrogen need to be transformed into liters of hydrogen, and as we are working at STP conditions, we already know that 1 mole of any gas at those conditions will be 22.4 liters. So I just use this. I will have 1 mole of hydrogen here and 22.4 liters of hydrogen. And here is where I will stop. Here the unit will be liters of hydrogen. If I cancel the units just to be sure, grams with grams, moles of oxygen, moles of oxygen, moles of hydrogen, then I can do the calculations. Now it will be 55 times 2 times 22.4 divided by 32. The units are already liters of hydrogen, and then it is 55 times 2 times 22.4 divided by 32. We have 77 liters of hydrogen. This is the amount of hydrogen that will be produced in liters at STP this is the amount of hydrogen that will be used to react with the 55 grams of oxygen to produce the amount of water we calculated in part A of this problem. If you want to use rules of 3, you can either transform everything to grams or everything to liters, or use 3 different rules of 3. 1 to transform the grams of oxygen into moles of oxygen. That will result in doing these calculations. Then the second rule of 3 will relate this with this, and the third rule of 3 will relate this with this. Let's do it just for you to see how it can be done. Step number 1, grams of oxygen to moles of oxygen. If 32 grams of O2 are 1 mole, 55 grams of O2 how many moles? It will be 55 times 1 divided by 32. Here we have 1.71875 moles of O2. If you want to round it up, it will be 1.72 mole. Then the second rule of 3 will go like this. If, according to the balance equation, 1 mole of oxygen uses 2 moles of hydrogen, this is supposed to be an H, then 1.72 moles of oxygen, how many moles of hydrogen will it use? So again we have this times this divided by this. This is supposed to be a division sign. So now it is 1.72 times 2. Here we will have 3.44, taking this rounded number, moles of H2. The third rule of 3 will be transforming these moles into liters of STP. So let's do it. And we already know that if 1 mole of hydrogen at STP is 22.4 liters of hydrogen, then the 3.44 moles, the 3.44 moles that we have already calculated, how many liters will it be? So it's just 3.44 times 22.4, and then we have the same amount of 77. If you cut the decimals like I did, it will be 77.056 liters of hydrogen, but it's still the same result. So these are two of the many possible ways to solve problem 1b.